Yes, my name is Jered Masters. I'll be presenting the philosophy of UAVs. And just quickly, I'm going to explain. I wanted to do this talk because I work with UAVs and I get asked questions about it a lot, and I go into debates a lot about it, and it seems to be something that people are concerned about. So I wanted to address a few things that come up a lot, and I wanted to create informed debate essentially about where it's going and what we can do with it. So as an introduction, apologies. What I want to convince you of tonight is that UAV technology is going to be everywhere, and that it's going to raise challenges for us, such as what I've mentioned, these debates and issues people have brought up. These challenges are going to be emotional challenges, they're going to be moral, ethical, and political challenges. So for an introduction, briefly myself, I was previously a research and development engineer, and that's how I got into, got into UAVs. My job was to find new exciting technology and take it to my boss and tell him about it. Well, that's not really, that's what I thought it was. I sort of felt like it was quite exciting. Before that I was a programmer. When I was an R&D technician, one of the technologies I found and made a case for was produced by a company called Sensefly over in Switzerland. They produced this UAV. It was a small piece of foam, 80 centimeters across. It was cut, obviously, conveniently into a wing shape that would fly around and take pictures. And it would be able to map and model different terrains and landscapes. I'm now a software development manager at HLGS at Valley Leicester. And I've studied computer systems engineering at Curtin. And in my spare time, amongst doing all that, I'm a hobby enthusiast getting into robotics and UAVs. UAVs themselves, for those of you who don't know, it's an unmanned aerial vehicle. They're also known as drones, and this is the word the media uses to scare people, and why people are so concerned about it, and I get a lot of queries about it. The US military defines UAVs as capable of operating without an internal pilot. They're tethered by radio to a control link and can be programmed for both flight and payload operations prior to launch. So they're different from a remotely operated vehicle because in the way that they can be programmed to follow a path and they can be programmed to do tasks without a person manually controlling it. The reason you would choose a UAV to do a task is because they are cheaper, faster in most applications, so cheaper and faster, and you can send them somewhere without having to send a person there. So in most applications, they're considered safer as well. And in my work, I've actually come across a person who's legitimately bought one and told me that his reason was because they were fun. And this was for an industrial application. So they are starting to take hold. So what can they do? I'll briefly touch on a few areas of where they're moving into already. Obviously, there's more. These would be the major ones. The industrial. For rescue, Boeing has created this scan eagle. Now this does a similar thing to the product I mentioned before. It flies around and takes photos of the landscape. But this scan eagle has been equipped for rescue missions. There's also survey applications, which is what my company is primarily involved in. Now this is a product made by the company I mentioned before. This is the Model 2. This EV, it's called, it's a small UAV that can fly for 45 minutes and captures about 2 square kilometers of photos. Those photos can then be computed into a 3D model using algorithms and processes called photogrammetry. That 3D model can be used to create measurements, do designs, do plans. It's a very, very useful thing, which currently to acquire that is, you pay probably about 10 times as much for the equipment, and you have to pay more for contractors. The closest equivalent system would be LiDAR. For those of you who know the industry, LiDAR is a system they currently use to do the same thing. They capture landscapes and models. And this is as accurate as LiDAR for, as I said, a tenth of the cost. And automated systems. I'm not sure how well you can see it here. This is some quadcopters building a structure of foam blocks. And this is quite exciting. They built this in about 4 hours, I think, a bit over 4 hours. And they fly quite fast, they're able to dodge and avoid each other. Now, foam blocks isn't very useful, but you can see what this technology can do. motion sickness. Domestic. This one's quite interesting. I'll zoom in on this one for you. This is, I'll zoom in again. This is a company over in the US which sells burritos, and what they've designed is a plane that delivers this burrito to the purchaser by parachute. I thought that was pretty cool. And here's a happy customer in his convenient land and field 400 by 400 meters out in front of his house. Now, hobbyists are also getting into this. This technology is becoming incredibly cheap, incredibly easy to set up. So we're starting to see a lot of people that are purchasing this technology and flying it around the metropolitan and rural. And that's something I'll go more into later. The military. Military are getting into this technology too. This is the Predator. The Predator is the rock star of the UAV industry. Everyone's heard of the Predator drone. This is the one that's on the media. This is the one where you see a fuzzy photo of a target and then it will get blown up, or some person behind a control desk will allow them to carry on. This is the drone that is scaring everyone. The US military uses this drone quite a bit, and so that it can be used for strikes or for recon. The next one I want to point out is the Falcon. Now this one is experimental still. It's not operational. It flies, the current model flies 27,000 kilometers an hour, fastest aircraft humans have ever built. It's designed to carry military strikes out on the other side of the world in less than 60 minutes. If you do the math, you won't get there in that speed. That's because this isn't the final model. But they're currently in debates as to whether this is a UAV, so whether it's an aircraft, a spacecraft, or a missile. It's designed to impact the target and destroy it. So people argue that it's a missile, but it doesn't carry any explosives, but it also circumvents the globe on the very outer edge of the atmosphere. This is how it prevents from burning up. So that's what the military are doing with this. And this is open source. It's not necessarily an application or an industry, but it's a really good indicator of how fast this technology is growing and how fast it's picking up. Open source is it's a system, I'm not sure if many of you know, it's a system where people will supply their designs and detail and code on the internet for free. So more people can download that, edit it, improve it, upload it, produce it. It's a fluid kind of community. And it makes it very, very cheap and very, very available. So this is why it's driving hobbyists. There's a lot of hobby-style open source systems out there. This top one up here is called the Crazy Fly. This is produced by a company called BitCraze. This is about the size of your palm, about 10 centimeters by 10 centimeters. This runs Linux and can be used in multiple applications around the world. This down here is a project that I'm currently working on with a friend of mine. This is a hexacopter, which we built almost entirely out of open source parts. Obviously, there was a few things like motors, which we had to buy from proprietary vendors. But this is fully operational and it looks pretty cool in the dark. So now, what impact is all this going to have on the society? There's philosophical concepts of the greater good. I'll explain that briefly. If a healthy man walks into a hospital and there's 5 people who all need different organs, is it philosophically correct or is it ethically correct to kill that one person and give the 5 organs to the other people? Most people would say no. Hopefully, everyone in this room would say no. This is a philosophical argument called the greater good. It's based around the concept that each person has internal rights and privacy that can't be voided by the greater good. So even though you say 5 people by killing one, we can't do that, and that's very good thing. Now this is a quote that came out after the NSA. I'll read out only Benjamin Franklin's one because Obama isn't really relevant. Any society that will give up a little liberty to gain a little security will deserve neither and lose both. So this talks about, the reason I put this up is it talks about the privacy issues that people are coming up with. Now there's war games. This is a great piece of artwork which turns a chess set into a nuclear bomb. As you can see here, we can now kill people from a long way away. And fairness, I have to skip over fairness, sorry. But fairness is something that's evaluated by a veil of ignorance. It's a concept where what would you choose for the laws if you didn't know which side you were going to be on? Example, cutting a pie, if you didn't know which piece you were going to get, you would cut it as evenly as possible. Alright, now this is the tragedy of the commons. Very briefly, what would happen if everyone started buying levies and flying them? It would become incredibly dangerous because they could be crashing, there's no testing for this, they could be crashing into highways and such.
If you can get all of these parts and make one of these devices through the internet or through shareware, doesn't this become an issue for terrorists because they can do it as well?
Absolutely, yes. There have actually been discussions on forums about whether or not to take down designs for this, but it's a very common open source problem. There's been an open source device shared called the wave bubble, which knocks out communications on all frequencies, and that has been downloaded thousands of times around the world, and it's been stamped out by government agencies, obviously, because it can do quite a lot of damage. But yes, there is a lot of problems with releasing certain types of open source technology. You're right.
You thought about using this in countries where communications, physical communications between places are difficult. Let's say in small rural communities where scripts need to go to the doctor in the town or the chemist in the town, which have to be filled and come back to the community. It takes a day to get there by horse and cart or something. This is the type of place where this could come into its own very quickly.
Yes, it is. It'd be an interesting discussion to see if the economics of producing an UAV that would make that trip the arguments for it outweigh the arguments for creating a data connection. There are simple ways to overcome those problems, but as you say, in these sorts of countries, they're very, very difficult to come by.
What sort of payload would they have? You could send the scripts and return them the medicines.
Yes. This device up here, one I mentioned first, this one is for the distance it covers, it's probably the lightest one that would be able to take a script back and forth. This one can carry up to 200 grams, and so you could carry the script and bring back medicine, you're right. Interestingly, a competitor to the manufacturer of this product actually, in a press release, talked about how his UAV could be used to transport organs, which is ludicrous, really, when you think about everything you'd need to transport an organ. It wouldn't be just the organ. You'd need to have certain cooling systems and things to keep it alive. But in the press release, he said it could fly from one hospital to another and go straight to like a helipad or straight in the window where they're operating. Any other questions? Yes.
How far off is this from being automated for public transport? I mean, is it in the foreseeable future that these sorts of UAVs will be replacing pilots and stuff like that, or because because it's reducing perhaps the margin of human error for commercial flights and that sort of thing?
So you mean UAV carrying a payload of passengers?
Yeah.
At the moment, when an aircraft takes off, the only thing the pilot does is the takeoff and landing, and they're trying to automate that as well. I guess what you're talking about. I'm not sure for passenger aircraft, as when you involve humans actually being a computer being responsible for humans, it gets quite difficult and quite messy very quickly. But like public transport systems, the train system, that's almost entirely automated, but they have a driver sitting there just in case. So I imagine if it did get to that, we'd still have a human sitting in the cockpit just watching everything. So the economic benefits aren't quite there yet. Yes, sir?
I was just curious, are there sort of, with the current UAVs that are out there, are there sort of limitations as to how high they can go, withstanding atmospheric conditions and things like that?
There are limitations. The manufacturer will specify the limitations for their area. That's where they've tested it. They don't want to test it somewhere else and then say it's fine there. But in Australia, where we have different sort of wind currents, you could lose signal or could fly away very easily. When the biggest thing I think for the small UAVs, if the air pressure doesn't get them, if they're light enough to be able to battle the issues of air pressure, the lipos actually fail when they get up too high. The highest I've pushed the UAV, again, the small one, was up to about 2 kilometres. And for those of you trained pilots or CASA representations in the room, we did have a trained pilot there, and it wasn't in a rural area. We pushed it up to about 2 kilometres. We couldn't see it anymore, and so we had to bring it straight down. So they can go quite high, beyond what's useful, I feel. Yes?
Say like one of the UAVs loses connectivity to the control. Is there any sort of system that protects people from the debris of this falling aircraft?
Well, the most basic system would probably be get back in your car. But when they lose connection, they are entirely autonomous. So they follow a GPS path, and you can give it settings which will either return it to home if it loses connection, or it will carry on its mission. And you can also specify a timeout period of 2 minutes or such. So we've never had an issue where lost connection has brought down a UAV.
And for one more.
In your opinion, what's the greatest challenge for endurance of UAV? What exotic technologies do you think it will overcome?
The greatest challenge would be the energy source on board. There's obviously been electric and petrol investigations and research been done. The longest flight time of a UAV, off the top of my head, is 156 hours. And that was by a military project where they had a 20-metre wingspan on this thing. And it took a couple of people to stand underneath and throw it to actually get it launched. But it had solar panels the whole way along. It's this big curved thing. So in terms of longevity, I'd say energy is definitely the biggest issue.
We'll finish up the questions there. Thank you very much, Jered.